how to download, install, and use ImageJ. And the primary uses for ImageJ are to retrieve images, quantify Lacteal ratios, or for any other image alteration or modification. So to get ImageJ, I'm going to put this link inside of the description to download ImageJ, and all you need to do is, depending on your software, we're going to download Fiji, so we can go ahead and get the latest download. You can go ahead and press US if you have Mac. You would press ARM if you're running one of the newer laptops, and then same for Windows if you're using that. And once that's done, it'll take you through a setup process, and you'll end up having Fiji open, and it'll end up with something like this. Once you have been able to install Fiji, which is just ImageJ with a few more plugins that are bio-oriented, the next thing we're going to have to focus on is finding an area to store all your files. So for most people, the size of those files that are being transferred from the microscope are likely to be very large, and if possible, you might not want to store them on your laptop if you don't have enough space. As such, I have all mine stored on Google Drive. So for this account, I just created a folder that has all the files that are associated with this certain image or certain mouse in this case, and each of these are separated by date just so I have easier access. So when these files are transferred, in most cases, you're going to have a lot of these different files. You will have, in general, 3 types of files: the text files, the IMS files, and or I guess the deconvolved metadata.txt, and then just regular txt. And then you'll have these regular IMS files. So the difference between these are the metadata are text files that we don't work with, but the IMS files are what we do work with. In general, when you work with these images, we want to use the deconvolved as they are better to use for viewing in general. However, there are cases where the deconvolved file doesn't properly transfer from the microscope, so sometimes we might have to stick with the regular IMS file as we see here. And I find it easy to just use some type of tagging system, or I've used a color tagging system here to just assign what I have to do. And if I've already done it, I assign it green. If I haven't done it yet, but I need to do it, I'll assign it yellow in here, and then change it to green once I've finished it, just to kind of keep in track with these longer names. And if a file doesn't work, for example, this deconvolved version of this file does not work, so I marked it red just to move to the IMS file. Here we've gone through this area for storage of files, just use organization. So in my case, I have different uses for these images. In one manner, I might be using them to extract a single channel or color image. As you can see here, these are all green to represent one of the markers used for that specific imaging, and I've saved them here just to indicate that those are from that certain image. And I've done that across the board here. However, if you are quantifying, and in my case Lacteals, for values such as length, it'll be better to use an Excel sheet here to save those values and be able to use them in finding averages or medians. The first step for opening up images in Fiji or ImageJ is we need to open up the application first. So we can go ahead and open up Fiji here. So the first thing we're going to do is, there's actually 2 ways of working with this. If you're on Mac like I am, you can see that all my options are up here for any of the features that Fiji allows me to use. But if you're on Windows, most likely it'll be somewhere above this, and it'll say like File, Edit Image to be able to do those things there. All right, so when we do this process, first thing we can do is we can either drag a file directly from this list of files that I have, and for my case, I'll be opening up a new file, one of which I haven't done, and we're going to try and open it straight from here. So we can either drag in and drop it directly on. If you don't want to open Finder or the folder, the File Explorer for Windows, then what you can do is you can hit File, Open, and it's going to give you the same list. It's just going to be in this form where it's directly in the application, and we're going to go ahead and select the file that we want to use. And I'm using the deconvolved file here, and we're going to go ahead and hit Open. And in many cases, these files are pretty large, so it's going to take a while to open. And once we import this, we're not going to change any of the settings here. They're all preset to what we need. We're just going to hit OK. And I don't know if you can see here, but there's a large progress bar, and it may take a while for this image to open. It's about 1.61 gigabytes, which is pretty large, so typically you're going to have to wait a while. I've waited up to 5 minutes before just for a file to open, so just be patient depending on how fast your computer is at opening these. And in my case, it's opened it up pretty fast, or at least this menu. And here, once again, we're not going to change anything. We're just going to hit OK. And we're going to wait for it to open. So when we first open up the file, the first thing you'll notice is the image is a bit dark, or at least the color of the channel at which it's showing is a bit darker. So this C here stands for channel, and it just talks about the 3 channels that are here. In this case, we have blue shown kind of there, green, which you can see a little bit of, and red. And these go along with the different markers. And the green, I know for sure, is Live 1 488, which marks the lymphatics and the lymphatic vessels. Additionally, we also have this bar down here for Z, which corresponds to Z stack. And it's just going to show you different, through those different frames, the different parts of the image that it's taken. So we could consider that something that we really don't need to touch. I mean, the channel you can use to select what channel you want to, or the color for the channel that you want to, in this case, if you want to change the values for your brightness, contrast, minimum or maximum. So you're going to need to, they're split here, so you're going to need to individually do them before merging them all into one channel. And in my case, I need to figure out whether I can take the lacteal quantification by seeing if this is a picture of a slice of the lacteals that are there, or if this is the extracting the lymphatic vessels, a picture of the lymphatic vessels, which we will only need the single channel for. So the way we can tell is if we have that one thin slice where lacteals might be sitting on the outside here. However, if it's just a picture of all the vessels, you'll see it throughout the screen, and you'll know that that is just the image that we need to take. So I like to start out just before we start by doing any of the image modifications, just to adjust some of the color values to see what we're working with. And there's two ways you can do this. You can either make a shortcut to find that specific action, or you can go to image and you can go to adjust, and then we can do brightness / contrast, or you can see it's Shift Command C, and then this will pop up here. And this window is important for changing those colors. We have minimum, maximum brightness and contrast. And what you're going to need to do per channel is just adjust these values. So we can kind of tell what type of image, if this is a quantification or extracting that, that image of the live one channel. And what we're going to do is, normally auto works pretty well here. So we're going to hit auto. And as you can see, we don't see much of those lacteals hanging off the side. So my guess is, the villi with the lacteals inside hanging off to the side. So my guess is that this will likely be a image extraction. So we're only going to need the green channel in this case. And let's just make sure. Yes, and you can see we have a lot of vessels here seen throughout, but we do have a problem in which there's a lot of vessels here that we can't see, and sometimes you might not be able to retrieve those vessels with current imaging techniques, as they just might not be visible no matter how much you change these values. But let's try our best. I think we can get some of these out. So the first thing we're going to do is we're going to go to image, and we're going to go to stacks, and we're going to select a Z project. And just going to say Z projection. It's going to tell you the number of slices, and that correlates to the number of times you can move the slider down. So it'll be like about 44 times. And we're just going to leave all the other settings the same, and we're going to hit OK. And a quick note here is if this image is miscolored, so in earlier images that I worked on, I would need to separate all these different channels together, separate these channels and then merge them back together after, just adjusting the color and the Z-stack settings. So in that case, if you wanted to, you could press LUT, and you can choose any color you want here. For most of our work, it was changing so that macrophages highlighted in the image would be cyan, if it was sometimes misplaced with green for lymphatics, but you can change the color of this and it'll change it to cyan. But we're gonna go ahead and stick with green here. All right, so once we've gotten this Z-stack, which is this AVG average, which stands for the average intensity that it took from that Z-stack, we can go ahead and close this as we don't need it. Oh, and it seemed to have gotten some more of it. So what we're gonna do is we're going to hit image, go to color, and we're going to split these channels. So it's gonna split into 3 different channels, and if I move this around, you can see the 3 different channels here. And in our case, we only need to retrieve this one green. So we can go ahead and close the blue and the red. If you were merging them, you can go ahead and save them, and the same thing you would do, you just hit image. After you've edited some of the color value, you can go ahead and edit it at the end too, once you've merged them. So if it's overlapping another color and it seems like it's too strong or not strong enough, you can go ahead and edit those values. But you would do the same thing, go to image, color, and then merge channels, and then you would choose the channels that you want. Most of the time, the 3 available channels that are there, which is the blue, the green, and the red, will automatically pop up, and you would just press OK and keep moving on. If it doesn't, you can manually change them. Okay, so now that we have this image there, one of the most important things that you make sure you do every time you want to change a value of some sort in this image is you want to press on the tab that you're actually working with. Sometimes if you don't, it'll remove all the options and it won't work. And that's happened to me a couple times, so just be wary of that. We're gonna go ahead and press on this tab, and we can go ahead and press on this brightness and contrast. So let's go ahead and do auto. All right, and we see that it's worked here. And this doesn't fit my screen fully. My screen isn't big enough to hold it. So what we can do is we can zoom out on the image just so we can go ahead and use this and scroll up and down to kind of see if the lacteals here are being shown or they're kind of being dragged off. But what else you can do is, if you don't really need to look at the image in depth right now or at full volume, we're just looking for the entire image, you can just zoom out and it'll make it slightly smaller. And I think we can do it one more time. Just go to image, zoom out. You can also use command minus or plus for zooming out or zooming in respectively. There's not really a set way to tell if you've got like the perfect exact things that we need, but in most cases what we really want to look for is we want this greenish background that are not the vessels to be a bit darker, sometimes black if we can get it to contrast these vessels and make them really pop. And the reason we want that is there's another software that will go ahead and trace these vessels and take measurements, so we want to get it as accurate as possible, and we don't want the background to interfere with the lymphatic vessels that are shown in here. So we can try our best to get this, and it's very subjective in terms of what is good. And yeah, I think we've kind of gone back to the original image that we retrieved, maybe a little bit lighter with the vessels, showing a little more, but it's a little bit clearer, at least for the software, to be able to see, okay, I see these vessels right here, vessels moving through here, and be able to outline them. So I think this is a good point where we can go ahead and save this image. So when you save any of these images, we're going to be saving them as .tif files. And one issue with these TIF files is if you save them, normally they will resort to grayscale. So if you're exporting these images for viewing use or for presentation use, this will not be effective. So what we have to do is change this to an RGB image. All you have to do for that is you're going to go ahead and just press on this Fiji window, go to image, type, and right now it's at 16-bit. We're just going to change that to RGB color and change it to RGB. So normally if we save this, it would default to that grayscale looking image, but we've retrieved this this colored image. So then what we're going to do is we're going to hit File, go to Save As, TIFF, and we're going to just select the folder that this image is housed in. So remember I created these folders for the correct mouse, so list, yes, where we have these. So this is from 6:30, June 30th. So we're going to go ahead and find, so this is from, these are separated by the mouse. So this is the first mouse, second mouse, third mouse. This is found from the third mouse. So we're going to go ahead and open up this third mouse. And as you can see, I've already done some other ones. So one thing I like to do before fully saving this is I like to go to the end of the file name and just change it to whatever the marker is, whatever the marker that illuminates. So for example, this green would be live 1.488, and you can see that's kind of right here because that's what we're looking for. So we can just go ahead and put in live 1.488, and that looks good. So we're going to go ahead and just hit save here. Second part of this tutorial, we're going to look over how to quantify lacteals. And when I say quantify lacteals, I mean we're going to measure out these lacteals in relation to the total length of the villus, or in plural villi. And just for some context, the villi are these, it's the layer outside these hair-like projections that protrude out. And inside we have the lacteals that we'll see in a second, which attach to those lymphatics in the middle of the system. So we're going to do the same thing that we did last time. So all I've done is I've opened up this file, which is for quantifying lacteals. This is just another type of file that I received, and we're using the deconvolved version as it has opened properly. And it's a similar setup to the last image. We have all 3 channels here. Once again, we're only really going to need 2 of the channels as we're measuring the lacteal versus the villus, which is shown in blue here. And then the blood vessels are really irrelevant in this form as they're just scattered throughout, and you can see them here. So I choose not to bring them in just to reduce the amount of extra color that's in the image. All right, so first step is going to be the same. And for changing the brightness and contrast, you can do it in either order relative to starting the Z-stack and then separating the channels. I prefer to just do it ahead of time. It just feels easier for me. And instead of using these menus options at the top, you can see there's little shortcuts here that you can use to open up those to perform this function. So for example, if I want to do, if I want to open up the color and brightness, or the brightness and contrast tab, I'm going to go ahead and press Command-Shift-C, and that opens up this right here. So I can go ahead and just press auto. Can go ahead and change that auto. And you can see here it's kind of still unclear. I'm going to do a bit of manual changing just to get enough so that I can see what we're working with. So yeah, it seems like, and remember in this scenario where we're quantifying the lacteal villus ratio, we're not going to need perfect images. We really just need an approximation using these colors right here. And we can just kind of see here, I'll go ahead and, we could just use a single channel to try and do it, but I prefer using the blue channel too, just to get the outside edges, just so we can see how long it really is. So we're going to do the same steps as last time. We can go ahead and edit this after if it seems like it's too distracting. So image, stacks, then Z project. Okay, so now that we've done the Z stack, we're going to split the channels. We're going to image, color, split channels, and now it's split. So we're going to need to merge these two just to get these images rolling. And once again, I do not need the channel that portrays the blood vessels, so we're going to go ahead and close that. So we're going to press on this Fiji image bar. Remember on Windows, there'll be options here. We're going to go to image, color, merge channels. So here we have the different channels here. If you have more than 2, for example, if I kept that red for blood vessels open, we would have a 3rd channel and we can just include it in there, but it's auto-selected to what we need. So we're going to just ignore, and you can go ahead and change if you don't want the source images. For example, if I don't want these to still be here, I don't have any use for them, then I'll uncheck this box and it won't keep the source images. But sometimes if you make a mistake while doing your color grading, you might want to go back, and that might be useful, but for now we're just going to leave it out. I can just reopen the file if need be. So it creates this composite with the 2 channels, and remember we still have this slider here, and this is very important as it allows you to pick which color you want. And sometimes this graph will give you an indication of what color you're currently working with, right? So right now we're working with the blue channel. It's very tough to see, but there is this green channel, the indication for a green channel. And I think this is pretty useful for, or at least the color scheme we have now is pretty viable for quantifying these lacteals. And as you can see, these the lacteal ratios is what we're trying to quantify, but we have an abundance of various villi moving throughout different places, and it does take quite a while to get used to figuring out where what is what and how things move. I think we can do a little bit of modification to the screen channel, and look, I did a pretty good job here of just removing any of the extra, but I do want some. It's okay if we have that. We'll go ahead and yeah, so I think this is pretty good. So all the lacteal ratios are is a measure from the base of the villus to the tip of the villus. So in this case, I'll just go ahead and start with this one because it's the first that we can see. This left one, the villus is cut off, so it's not very usable for quantifying this ratio. So we're going to start around this point. So it's where the bottom, the base of this villus is, and we're going to just draw a line through the tip. And then the second time we go through, we're going to approximate the same spot, and we're going to do it to the tip of the lacteal. So remember, this green is lacteal and extends from these lymphatic vessels. If we were to expand the image, and if there were more to the image above this, it would just be that same picture from last time where there's many vessels moving through and connecting through these lacteals. So we're going to start with this lacteal just to measure. And before you measure, the first thing I like to do, if the image has a scale in the bottom left, this one is already to scale. So every micron is a certain amount of pixels in this image, and it automatically calculates it. But if you do want to see, if you have a scale and you want to set that scale, we're going to go ahead and move to set scale. In our case, we don't need it. So yeah, we see here it's 3.3169 pixels for the known distance of 1 micron, and you can see that scale is right here. So we don't need to change this. We can go ahead and leave it as it is. But if you were to have that scale, what you would do is you would zoom in to the image, and you can see kind of where we are. And imagine there's a scale kind of built along here. What you could do is you could take this is the first tool we're going to use, which is the straight line, and we're going to start where there'd be a bar here, normally where the scale starts, and you would first drop your mouse there and press down. And to keep a straight line, what I recommend doing, see if you kind of move, it can go at an angle. All you can do is just press Shift, and if you move your mouse, it will kind of stay no matter where I go, unless I move it 45 or 90 degrees from the original place, so 0 degrees. And we would just set it to the scale, so whatever the scale is, we would quantify that amount with this line. And then following that, we'd go ahead and press this, go to Analyze, go to Set Scale, and you can see the distance in pixels here is like 561, and I could say that the scale given to me, say it was like 50 micrometers. I could go ahead and say that here that the known distance is 50 for whatever this is, and the software will automatically calculate the scale based on those numbers. So for me, that's not relevant as it's one-to-one already figured out for me 3.3169 pixels per micron. So we can go ahead and press cancel, and I will not need to do that. So let's go ahead and zoom back out to our full image here. And we're going to use a new tool. So realistically, the only two tools you're going to need are this freehand selection or the straight line. And I like using the freehand selection if my lacteal is not a straight line and seems to be curved. So in this case, you can see that if I draw a straight line, I really can't get to the end of this villus. So what I can do instead is, this is a little bit tougher and it's a little bit less accurate as you're not really moving perfectly in line with what a straight line would be. But we can try our best to kind of move, and we want to get through the center of this lacteal. The lacteal is kind of like a guide for measuring through the center of the villus. And then we would just end at where the tip seems to be. So we can take our first measurement. We'll just start at where, and we're going to drag our mouse as we press through to the end. So it looks like the base is somewhere around here. It's sometimes tough to tell, especially with all this extra noise. I can go ahead and try to remove it, but it doesn't really do too much of it. Actually, it helps a little bit. We can see a little bit here. So one thing I do have to mention, though, is when you use the freehand selection, you lose the angle. So when you're with a straight line selection, you get an angle of the line compared to like 0 degrees. However, with a freehand selection, the line is curved, so there's no angle really that you can measure. So that's one thing you do lose. Keep that in mind if that's important to you. But in our case, we don't need that. So we're going to start by indicating where that line starts, and you can go ahead and just draw through the middle. It won't be perfect, but just good enough to get a good measurement. And I'll stop there at the end. Okay. What we've done is we've created this freehand selection, and this is nice that they've given us this line that connects. So if you just want to find displacement rather than distance, that's good that we have that. But in my case, I don't want just the displacement. I want the actual distance. Press Edit, go to Selection, and then we're going to go to Area to Line. And I've saved this as a shortcut in my own personal settings, and I'll show you how to at the end. But now that we have the line selection rather than the area, what we can do is we just press M. So there's two ways to do this. We can go to Analyze, Measure, and the shortcut here is Command M, but I think M also works as a shortcut. If not, just do Command M, or you can go ahead and manually press the tab. We've just pressed M. And on the screen, this will pop up. And as you can see, I talked about this earlier, but you normally have 6 categories: area, mean, minimum, maximum, length, and then there'd be angle. Or angle would come before length. In this case, it's going to show up as 0 if you try to, if you start with a straight line and then you put in one that has a curved line that's not straight, it will come in as 0 for all the curved lines. But in this case, yeah, we just have these 5 options, and later when we move to the Excel sheets, we're going to need to modify the data a bit to be able to fit this in. All right, so we have our first measurement of the total base to tip of villus length, and in all of our cases, we're trying to find that ratio, right? So in all of the maximum ratio that we have is 1. If you're getting a ratio when you go through Excel sheets that is greater than 1, that means you made a mistake, as a lacteal is protruding out of the villus, is what that would theoretically state, but we know that's not true, unless you do see that clearly on the imaging. But in our case, we don't. So we know that we would have an even number of measurements at the end when we're all said and done. So for every second measurement, it should be larger than the one that comes before it. So for example, if I take another measurement, it should be shorter than 229.316. So we're going to go ahead and do the same thing again, right? So we're going to start approximately in the same location as previous, and we're just going to draw a line through the middle. Once again, it's not perfect, but it's an approximate line, and we're going to edit, selection, area to line to get rid of that. And we're just going from the base of that lacteal to the tip of the lacteal, okay? And once we've done that, we're going to hit M again. It's going to measure that length, and as I said earlier, right, this length has to be shorter than that first one, and we had that as we can see here. So I'm going to go ahead and do this for all the other villi and lacteal combos. We've completed quantifying the lacteals, and we have a list of all the measurements right here. And as you can see, we have 16 that we got, so those are 8 villi that we can count. I discluded this last one over here as I couldn't see where that villus really leads to, and I wouldn't have a measurement for that value. So we have this set up. All right, so the next part of the lacteal ratio quantification is actually getting this into Excel. So I have a file open here, and the way that I organize my files are by the experiment. So this is an experiment from June 19th, and this encompasses all the mice that we've been able to take from that. And the way that I've organized each page is we have a directory of where I can find this file. Then we have the name of the picture. And here's the table that we've gotten off of the table from ImageJ. We have some other characteristics such as which villus it is, and in this next one we have 8 of them. So we're gonna have 8 right here. We have the length of the villus, the length of the lacteal, and then that ratio. And then this is just like an overall count, and I'll show you how to organize that. And as you can see, I've done some other mice here. So this is for the first mouse. And we have all these values set up right here. And the overall count, we have 218. And a good number, I believe, if you have many images for that mouse, a good number to have at least for the number of villi and the total number in general is around 160, so about 80 villi. You would have, depending on what type of experiment, like if we've done an insulin receptor knockout or if this is just a wild type, you'll have different average values, but this average just kind of takes, and this is a specific method of taking the average in Excel, is I've taken the average of this entire row. So no matter how long I keep doing, if I keep adding values, if I were to add like 1 right here, you'll see that my average will go up by a little bit, so it's at 0.564, but if you remove that, it's going to go down a little bit. So yeah, it's better to have a larger number, as a larger number of values means that we can get a more, at least per se, accurate average. And then it tells you the median, which is about 0.539 approximately for that ratio count. So that's kind of how we organized it here. And you can see all the name of the files, so we can easily sort through them. And so we're going to go ahead and press on mouse 4. And we have the first one down, and we're just going to paste the name of it. So the way I like to organize it is just have a space in between to give the title of the thing. And we're going to go back to Fiji, and we're going to press on any one of these values. Okay, and then you can go ahead and you can do Command A, or if you hit edit, select all, so select everything, and you can go to edit, press copy here. But for some reason, on my laptop at least, when I press Command C, it does not copy the values. It just copies them onto a clipboard, onto Fiji. So an easier way, just right click, press copy, and it's copied to your clipboard. And you're just going to do the first box, the very top left box. So in this case, I would have done it here if it were for that one, but for this one, we're going to press here, and we're just going to paste the values. We can hit paste, and all the values are pasted down. So I told you about those angle lengths. So any one of those selections where I had a straight line, I have these regular values, so -65, -67. So those are those angle values that I would normally find. But then if I were to have had all curved lines that are not straight, then I would have gotten 0 for all of these. Or it might have omitted this column entirely, and I would have had to manually input 0 and move the lengths over to the right. So remember how we did the villus ratios is by alternating every one. So these first two are would be one ratio when we go to do it. And for longer lists, you can resort to using external software such as ChatGPT, or finding any other way to get every other to be set up. I haven't found a suitable way in Excel to get that to work. But if you do find one, then go ahead and do that. But in general, I just like to take these values into ChatGPT and sort them according to the first value and the second value, so it's easier just to input them. So we're going to go ahead and number the villi. So we have 1 through 16, which means if we divide that by 2, we have 8 of them. So easy way to get these numbered quickly. So if you have many values, for example, sometimes I'll have 25 to 30 values for images that show more villi and lacteals. And what you can do is you can shift press down, And this little box, if you drag it down, and it'll count down for you. If you go to 8, it'll number them to 8 for you. So that's an easy way to do that. And now what we're going to do is we're going to copy every other value. So this column talks about the Villus length. So we can take that value and you can just copy, fancy Command V, paste it, and we'll do the same for all the others. All right, so once you have those values inputted, we're going to need the ratio lined up in this column just to the right of these two values. So the easiest way that I've found to do them, you can manually do them one by one, however you choose. Just press equals, and then I will select this value. And remember, we're doing a ratio of Lacteal to Villus. So we're going to select all the Lacteals first, and we're going to press Shift and press this last column. So it's going to take all those values, hit the division symbol, press what we want to divide those values by. So go ahead and press that, Shift press the last one, hit Enter, and they're all inputted right here. And so that's reflected here in the average or median. So that is the basics to being able to work with the Lacteal quantification, the ratio quantifications, and that's pretty easy to get through. Okay, so once you've been able to input those values into Excel, what I normally do just to kind of get this out of the way is I will change the tag on this to green and just remove the yellow tag so I know I've completed it and it's worked, and that shows up there. And I'll go ahead and close this as we don't need those values anymore. We don't need to save them. Go ahead and close this other image, close this, and if I'm working on more, typically I'll just go ahead and drag the next one in, or I'll just open it and get back to it. But one more thing I wanted to talk about before the end is just talk about some of these shortcuts. So instead of pressing each of these menus every time to being able to open a certain function, for example, to adjust, to open up this, this one already has a shortcut, but if I wanted to split the channels, there's no shortcut here. So an easy way to do this is if we go to Plugins, Shortcuts, and I would just list some of the shortcuts that I have and personally like to use. And the ones that I use right now is for setting the scale, which I can assign to any value I want. I made it 0, area to line to 6. I can also do measure for M. I think that's already put in. But yeah, those are the things that we can get working in there. So if you want to add a shortcut, you can just go Shortcuts, Add Shortcut, and then it'll automatically have them. But if you have a name of one that you've already done, that you know the name of, you can go ahead and input that in. But if not, there's a bunch of different functions on here that you can go ahead and assign to a keyboard value. And yeah, go ahead and choose that to your liking.